So, welcome all, and let's begin with our chapter number 4 with the continuation of its last topic, which is complex joins. Before moving into this complex joins, we had completed the types of joins in this chapter. You got introduced with what are the various types of joins and how those joins are performed and what is the syntax for it, right? So, we got introduced to joins, and there are types of joins: inner join, outer join. With outer join you have left, full and right join, correct? Apart from it, now let's get introduced to complex join. The word itself is complex, but it's not actually the complex way of joining. It's a very simple, but we'll understand how you can move ahead with writing your various tables into joining. So the objective here is, though it is called as a complex join, we also term it
Ashwin,
as self join. It
Ashwin,
is, yes,
we can't see your screen. You're showing or
done.
okay, yeah, now we can see.
Okay, so this is where this topic we are moving. So here we are into the joins of, or we call it as a complex, or it's also termed as self join. It's also termed as reflexive join. So when we say self join, it means one table can be joined to its own but with some other column in common with it, and we prefer it or we call it as a different table. So how it is, we'll see it in this topic. Okay, so moving ahead, let's understand the same thing through business scenario. You have two tables: employee address and employee organization. Now you know address is a table which gives you the information of your employee name, address details, correct? Whereas employee organization is the information about employees with employee ID, their name, their date of joining, and all other information with the organization, along with what is their job title, what is their underline manager under whom they are working with, from which country they belong to. So this is something which you'll get the information from these tables. So it's telling the chief sales officer wants to have a report with the name of all sales employees and the name of each employee's direct manager. We are working only with sales department employees. So the head of this department needs to know the employee details, their employee ID, and of course their reporting managers. Okay, so this information you get it through two tables: addresses and organization. So of course employee ID is common table column in both the tables. So you will have a inner join where you will get the information of this type. Fine. So the business data, what we are looking, it's telling to return the employee name and the manager name. You need to read the addresses table twice. Why? Because we want the information of all the employees and also the managers. Understand? Managers' information are saved into this address as an employee, whereas organization will have the information of managers. So here you have managers, here you have employees. So you may have the employees, the managers are also employees. So for those managers also you have underline employees, and the employees will have the reporting managers. Hence your address table you are going to read it twice. Are you getting it now? That's what it's telling. Employee ID and its name will be used to read employee ID and name. But the same you have, each employee ID also has a reporting manager ID. So each manager is also an employee. So see this manager ID 101, he is an employee here. Are you getting it? So this employee is actually having a new manager. But this manager is also an employee. Are you all getting what I'm trying to tell you? Everyone?
Yes,
So
yes,
you're going
yes,
to read address table twice. Once you'll be
yes.
reading it on employee ID, and then you'll be creating or reading the same for your managers. Fine? Determine the ID of employee managers. So you know you have every employee the information about its reporting managers as manager ID in organization table. So you get the information of manager ID from your organization table. But you are also aware that this manager is also an employee. He has an employee ID. His information is an address. So same can be read with manager ID for him as a reporting manager ID as well. Correct. So this manager is an employee and this employee also has its name. Correct. So return the manager's name. So that is why we are going to read addresses data twice. So required tables, we know we have addresses data to be read, and this addresses data will be reading it twice. So in your from clause, you can write employee address, you give an alias as E, and you can write employee address, you give the alias as M. So the same table will be reflected when you're using joins through SQL to be read as table E and table M. Are you getting it now? So this becomes two different table in your query. So in order to read from the same table twice, it must be listed in your from clause twice. Therefore, a different table alias is required to distinguish between their different table and its uses. All right, agreed with this?
Yes.
Okay, so we are going step by step. So now let's see your query. In your select, you're selecting employee ID column, employee name column, employee ID, employee name. So see, because you are reading addresses twice, because we want manager information also to be written into your output query, so that manager information is also in your employee. So you're referencing it to the table as M. Hence the employee ID is coming from M dot table and you're giving its label as manager ID. Whereas employee name, again it's coming, here also it's there, here also it's there, but this is for all the employees, this is for respective managers. Hence M dot employee name, you're giving its label as manager name. All right, everyone.
Yes, Ashwini.
Then you are doing inner join, you are telling SAS that you are also reading a third table, comma, Orion dot employee organization as O. Correct. So this organization will have the information about your employees, in which department they are working with. All okay. Then you are writing E dot employee ID is same with O dot employee ID and O dot manager ID, because you know organization has respectively a independent column of manager ID under whom those employees are working. Hence that manager ID is similar with M dot employee ID. M dot means where you are using it as manager ID. All right, see, with your same table. Are you getting it? And you're working only with department which contains sales. Order by country, fourth column and one column. So which is the fourth column? Fourth column is manager name. First column is employee ID. Country is coming from E dot addresses.
Ashwini, can you
Yes.
explain the where clause one more time?
Just observe this. Observe this. You have three tables. Address you are reading it twice with independent alias E and name. Third table is organization alias O. So with E dot employee ID is similar with O dot employee ID. Whereas manager ID from addresses M is similar with the manager from organization. Hence you're writing O dot manager ID is equal to M dot manager ID. So this is a type of join, and also you need to subset your report on the basis of department which has sales information. Correct? Yes.
Yeah.
So working with this, let's move ahead to read your or understand your table. I hope you people is aware that whenever we are going to work with an input source of data, you have to understand your input data set. So let's check for aura and dot employee and organization data. So we have address data, sorry, employee addresses. So this is the information of all the employees, irrespective whether they are managers or simple employee. So see, you have employee ID, their name, you have street ID as their address information. Then you have city, state, postal code, country, all this information. Do you see anywhere manager ID or do you see anywhere manager ID column?
No.
Look at this columns. So this is address data. But when it comes to organization, you have employee ID, job title, department, manager ID. So if you check this manager ID column, if you check any one of this 12010 in addresses, let's find out if we can find. You don't have this info. Manager ID. Let's check any one of it. In this we cannot see, like, okay. See here 120101. See here. Who is this? Is a manager ID here. Correct? Under him you have this employee. But the same manager is actually an employee in your address data. See what its name? Lou Patrick. Do you have this manager name here? No. But if you'll see, he's an employee. He has a reporting manager as well. But if you see this employee 12010, he is a manager for some other employee. See, same ID, same employee ID. He is a manager for this employees. Getting it, everyone? But if you see the same manager ID 120101 in address 120101, he's an employee. His name is Lou Patrick. Are you getting it? Hence, addresses table, we are going to read it twice. One as the information for employee and one as an information for manager IDs. Are you getting it now?
Yeah.
Yes, yes.
Okay. This is demo 14. Check this. See, employee ID, he has his manager and he's from this country. His name, his manager name. Same goes for most of the employees, their manager IDs and their names. So you have arranged the data on the column order by country. Then fourth column is manager ID and first column is employee ID. So if you go to this result, you have all the values first arranged with AU, which is in alphabetic order of country. So this was your Lou Patrick, who is a manager 12010 for this employees. Correct? But if you see this Lou Patrick, he is also an employee So you will find his name somewhere here also as an employee. Are you getting it, people?
Yes, Ashwini.
Great. See, see here, he is an employee. He has his manager whose ID is 12026. And Lou Patrick is also a manager for this employee. See, hence your address data you're reading it twice. And that is why we are using as inner join, where we are reading your employee address as E and employee address as M, and these two tables you are joining with your organization's data, where you have the information of all the employees and their reporting managers. Of course, we are going to subset your data within your department with sales only. Hence, the code is e.employee ID is same with e.employee ID of your organization, where you are doing inner join, whereas m.employee ID, which is equal to m.manager ID. So here m.employee ID is working as manager ID, is a column which is similar with the manager ID of this organization table, where you have only the information of employees and which department and under which employee manager they are working with. Getting? So this is what you are doing. So your same address data you're reading for manager ID, which is common with manager ID of your organization, and you're subsetting your data with department, which contains the word sales. Order by country, first column country, then your fourth column, which is your manager ID or manager name, because this is 1, 2, 3, 4, and one is the order of this column. Correct? That is why the result you're getting the order of all the values of country in ascending order, hence AU, US, C. Then the fourth column was employee, which is your manager name. Hence, it's arranging in within AU, it's arranging the values in ascending order of your manager name. And within these two columns, it is arranging the values of your IDs. Getting it now?
Yes, sir.
Great.
Yes, sir.
Okay. So if we check for this value, so see, though he is a manager, Davis Wilson, but he's also his employee, and he has a manager who is Lou Patrick. Right? So this is where you have done the joins. So you get this output. That's it. It was all about complex joins. So why it is called self join or reflexive join? It's because you have the same table, you're reading it twice, and the same table you are joining on the basis of a same column but with different name, hence you call it as a self join or reflexive join. That's it. All right, everyone.
Yes, sir.
So what
Yes,
you
sir.
can do is you just open this demo,
Yes.
work with this exercise or this demo, and of course open your tables, employee address and organization, and understand what you are doing. So you have this demo D0 or D14, and this is your business scenario. So look into your business scenario, read this slide from your PDF business data, understand this, and then execute on this demonstration. Go ahead. I'll give you 5 minutes on this, and then we can start with your new chapter. Okay. So let's start with an exercise with level 1 on page 4-37, exercise number 6, creating report with self-join. So it's telling create a report of all trainees and temporary workers to include their ID, name, job title, and their manager IDs and name. Order the report by employees IDs, label the columns and the title report. So you're going to use employee address data. These two columns you're going to use staff data with these two columns. Okay, and the report should be like this, where you have the information of job title, their reporting managers and name, and their employee IDs. So this is what they are telling. You are going to use address and staff data. So you're working with to create a report for all trainees and temporary workers to include their ID, name, and job title. So if you see their job titles, temporary, trainee. So they of course are from sales department. Okay. So yes, this Orion.staff table you need to open and understand. It's the data only for sales department. Okay. So and their manager IDs and name. Order the report by employee IDs, label the columns and the title report. So give the title and give the columns according the label. So this is the output to be seen. So which table you will be reading twice? Any idea? Yes,
Staff.
staff. Why so?
No. Address.
Address? Yes. So go ahead, write a query on this. So this is where you had the exercise solution on your screen, where you are using employee address twice. So you're reading at table 1 and table 2, and accordingly employee ID and employee name from one table, and A2 table is same employee ID as manager ID and name, and also you're using the third table called as staff. So this two tables, or this is the single table, but you are using self join as if they are two different tables. All right, and this is your joining criteria. All right. So with this, we have done with your lesson number 4. So we'll be moving ahead with your lesson number 5. So your lesson number 5 is all about subqueries. Fine. So we'll see what queries, subqueries are and how are they written. So query is nothing but your select statement, correct? Which we have seen how one can write a select statement in Proc Sql. So same select statement is called as query. So what is this? So it's telling subqueries. And what are its type? You have two types of subqueries, correlated and non-correlated. And of course, we'll see what is an inline views. So inline views, subqueries is nothing but your select clause or select statement is used in a various way in your program. Hence, it is termed as subqueries and inline views. So let's move with subqueries. So we'll define what is Proc Sql subqueries. We'll differentiate between correlated and non-correlated subqueries, and we'll subset data based on values returned from your subquery. So understand here with the business scenario. HR and payroll managers requested a report that displays job title for job groups with an average salary greater than the average salary of the company as a whole. So what we require, that we have a table for organization which has the information of salaries. So we will calculate the average salaries overall for overall the organization of staff. But we all want to find those employees whose average salary is greater than employees average salary, overall organization salary. So if you look into this table staff, so you have this table in your library, Orion staff table. So if you understand this table, you have the information which is for nearly 424 rows and 10 columns. You have employee ID, start date, end date, that means when they have joined the organization, job title. Okay, now end date, they might have not left the organization, hence there is no fixed end date, and hence the year is ending with 4 times 9. So wherever you have this type of information, that means it's a standard way of representing the data where you do not know what is the end value or the termination value, but you give this universal value. All right. Then you have this salary column. Of course, you have the information about their genders, birth date, hire date, term date, and manager ID. Because this employee has not left the organization, their term date is missing. They are still working. All right. So if term date is missing, that means you don't have their end date. Agreed? Understood this table?
Yes.
All right. So see, you have this salary. So in case you want as a whole the organization salary, how you are going to calculate it? Any idea? Yes.
Some
Some we want average.
average, then average.
Yes. So select. We will calculate its average. It's a function. Either you can write mean or you can write average. Both is going to be used in Proc SQL. So it is for your salary. Correct. And here you can give its column name as you tell it as average salary. Fine. So this is from Orion dot sales or staff data, sorry. So if I calculate this query or I executing this query, I get the calculated average salary. So what we have to do is we have to find out all the employees from this data who is earning more than your organization's average salary. Now you have this value, correct? Now when you have this value, what you do is you can write another query, writing proc SQL, select. All right. So what you are going to select? So as per the report, you want job title and mean salaries of these people who are earning greater than your employee's average salary. So what are we going to write? Select your employee name. It's only employee. So what's the column here? ID. Do we have name for them? It's job title. So ID they have just given as employee. Employee job title. Okay. So it's job title. Correct. What I'm doing, I hope you're understanding. It's job title column. So we are going to select job underscore title. Give it as a label.
We need to
Employee.
group as per job title and then calculate the average, right?
Let's see what we need to do it. So let's do employee job title and salary as a column. You give it a label. What is the label? Mean salary. Correct? From Orion dot staff data. Yes. Now what we have to do?
Grouping.
You need to first subset your data for all the employees who are earning greater than your overall company's average. That is what we had calculated separately, right? Hence, we are going to write where your salary column is greater than your overall company's average salary, right? So where is grouping required? Is anywhere grouping required here? Nilima?
Uh,
Others?
I think for each job title, we have to calculate the average.
So HR and payroll managers requested a report that displays job title for groups. Yes. So of course we are writing this, but yes, you need to have groups. Okay. So group by job title. Correct?
And we have to calculate the average for
So
right.
then this is not required here because we are grouping. So let's have having clause. Correct?
Yeah.
where you can have your salary greater than this value. Agreed or no?
Yes.
Uh, the column is average salary, right, for the company in the initial Proc SQL statement.
No, I did not get your question, Nilima. What you was telling me?
Okay, we have directly given the number. Okay, okay.
I've copied this number from here, na, this
Yes, yes,
result.
yes.
So will this give us the required result? So is it the same thing? Just so we have account manager. He has its average salary greater than company's salary. So is it the same thing? Yes. So this is a default format which is coming. Why? Because in your Orion start staff, if you see your salary column, it is having a format applied. $12 dot. Fine. That is why in the report you see this. So we get all these employees job titles who are earning greater than your mean salaries overall of your company's salary. So why we have the warning? Okay, so group by clause is working as order by when it's resulting into order. So did you get this? What we have done? Yes, people, are
Yes.
you all there?
Yes, Ashwin.
Or it's a weekend hangover?
There are only
So,
3 observations as per this slide, right?
right, how can they show you the whole thing? So this is what
Oh,
it's telling. It's
okay,
continuation.
okay, okay. Yeah.
Okay. So people, so what we have done, we had calculated this value separately as a query. But this is an output of this query. So every time it's not feasible for us to write two queries, one which will give you the average and then you're typing that value manually in your code. So instead of that, what we can do is we can write the same result which is coming as an subquery where you write this information as your subquery in your having clause. So I put this like this. Hence, I call this as subquery. So why we write here and how it is working, we'll all see. So the same query which was giving us the average salary, I'm using it as a query in my having clause. Hence, this is called as a subquery, where this query is giving the value to your outer query or passing on the value to your outer query. We call this subquery as a non-correlated subquery because it's a standalone subquery which executes by itself, and this value is been depending on your first query is depending on the value on this query. Hence it's called as non-correlated subquery. But this is how within a query I write a second query, hence it's called as a subquery. All right, everyone,
And we have to
Yes.
give it in the parentheses, right? Otherwise, it
we
will.
have to give it, otherwise it will be an independent query. You have to end this with a semicolon because this is one query, this will be another query, so it will be independent, so it will give you independent output. Are you getting it now?
Yeah.
But this is a part of this. See, your select is ending here. And within this, you are not having any semicolon. It's only a query in a parenthesis. Fine. So to achieve the same result, what we did it, first we need to calculate the overall company's average salary. So you write a independent query. Then you use this value to subset it in your main requirement, that how many employees are earning more than your average of their average salaries, then more than your company's salary. So these are some of the people. So see, it's telling it's a partial Proc SQL output. Fine, everyone. So this is what we do with 2 steps, but it's not feasible every time to write 2 steps. So this is where we come ahead and get introduced to your subquery. So you can write a program as a single step using a subquery. So subquery is a query that resides within an outer query. So this is your outer query, this becomes your inner query. So remember, in this scenario, your subquery must be resolved before your outer query. Why? Because your outer query is depending on the value which is passed on by your subquery, which looks like this. Getting it? So when we had executed this query, so this is what it has worked on, and it's giving you the output. So there is no special note for us, but this is what the result is. And this value is written by this query, which is nothing but that value of 30 and some average salaries, right? Some 38041. Correct? Everyone? So determine your job titles whose average salary exceeds company overall average salary. So same value you can pass it as in a subquery. So your outer query is dependent on this subquery. So your subquery is not at all depending on your outer query. Hence, this type of query of subquery is called as non-correlated subquery. All right. So there is a rule where you have to use this subquery in your code. I have used it in my having clause. I have used it only to query single column. Hence, it's telling that a subquery is written always in your where or your having clause of your outer query. Your subquery is always written in your outer query for the values which you're writing in your having or a where clause. All right, so it returns value to be used in your outer queries where or having clause. Fine. And a subquery should query always a single column, and it should return a single or multiple values. So it must return only a single column. That means it's querying only single column, and it can return either a single or multiple values. So this is how your subquery rules are. It is written always with your having or where clause of your outer query. It should query always a single column, and this query can return a single row or multiple rows. All fine. So this is what it's telling its position, either with a having clause as per your business requirement, or with your where clause you write a subquery. All fine, everyone.
Yes.
Yes, Sushma.
The same query, in case if you do not group by, let's see. In case, okay, I'm just telling you in case I use where. Okay, but your values are not in order. Okay, values are not in order. So in case you want that, and if you see the result, you have anywhere, no, fine. There is no duplicate values. But if you want the values to be in order, you can always write order by clause, order by on your column 1, which is job title. Let's check. Let's check with number. All right, so this is your first report with having clause, and this is your second report with your where clause. It's the same result. Check first 2 rows. Account manager 46090, account level 2, level 3, same thing, correct? Right, everyone?
Yes.
Yes.
Yes. So here you are not, here you are using group by with having clause. Here you are simply using your where clause. So I'm just trying to give you the example about how one can use it with your where and having clause, your subquery. So this order by is for the result for your outer query to be ordered, not with your inner query. Inner query is just going to query and give the values. Nothing order by clause is not valid with your inner query. Always make a note. It is written outside your outer query for your result. Right? Everyone, just try this code. Look at the screen and try this code, everyone. So this is where we always have a rule that your subquery has to be written with having or a where clause. It should query single column and it can return a single value or a multiple value. All right. So that is certain rules for subqueries we have to follow. So setup for the poll. Is the following select statement valid as a subquery? Yes or no?
No,
No.
Why?
2 columns.
Yeah.
Absolutely. So there are two columns which we cannot use in subqueries to be queried. Look at this query carefully. I hope you people are following. Shanmuga, Priyanka, Padma, Vikram, Monica.
Yes.
Yes. Oh. So subquery must return only values in single column. So what is a non-correlated subquery? So a subquery which is a standalone query which passes the values on your outer query and your outer query is dependent on your subquery. Hence, this subquery is called non-correlated subquery. So there are two types of subqueries. A non-correlated subquery, which is a self-contained query. It executes independently of your outer query. So it's not at all dependent on your outer query. Hence, it's called as a non-correlated subquery. Whereas there is a correlated subquery where your outer query passes the value to your inner query. Now, look at this query, employee ID average salary, where AU. Now, actually we write this value to subset as country equal to AU. But what we are writing where AU in your subquery country with work.supervisors employee address employee ID is common with supervisor's employee ID. So your addresses ID is common with supervisor's table ID, and you're selecting only those countries whose values are coming from the outer query with AU. Hence, your subquery is dependent on your outer query. Hence, this subquery is called as correlated subquery. So see, your correlated subquery requires a value or values. So either a single value or multiple value to be passed to it by the main query or your outer query before it can be successfully resolved. All right. See how it's written. So your outer query is passing on this value to be subset on country column, which is queried from this query. All right, people, everyone. So this is called as correlated subquery. This query is not standalone. It needs additional information from your main query. So how this non-correlated subquery? It will first evaluate. So it will calculate its average salary, which is this, and this it will pass on to your outer query. So you get the report where you got all the employees with job titles who are earning greater than the average salaries as a whole of the company. Fine. Okay, can a subquery contain a subquery? Any idea?
Yes.
Yes, you can have a subquery within a subquery. Now look at this code. This is one subquery. Within it, you are writing another subquery. So this is a code or a query where you are generating a report for latest orders for Orion Club low activity members, where you are selecting customer ID, maximum orders placed from order fact, and all the orders placed, which is later 1st Jan 2010, and all the IDs of customers who are coming from the values of this query. And again, this customer type columns values is coming from this query. And you're selecting only those results where you have club members with lower activity. So here you have customer table, you have customer type table, and here you have order fact table. And you're grouping by customer. So you can have a subquery along with a subquery within it. All right. So let's understand this through a scenario. So it's telling CEO sends a birthday card to each employee having a birthday in the current month. Create a report listing the names, cities, and countries of employees with February birthdays. So the CEO wants to send the birthday cards only for those employees whose upcoming birthday may be in the coming month, Feb, for that company organization. And those birthday cards needs to be sent for this employee managers, because the rewards are not given directly to the employees, it is passed on to the managers, and managers then give it to the individual employee. So this is the managers and their informations for whom the employees are working with rewards. Okay. So they are telling you have to create a report listing the names, cities, and countries of employees with the employee birth dates in the month of February. So for that, you have the information where you have name, city, address coming from address data, correct? So this is what it's telling, address data. You have ID, name, city, country. And if you want to know their birth dates, it will come from your payroll data where you have employee ID and birth dates. Correct? So you have birth dates. So you'll have to select the employees whose birthday month is February, and those employee IDs you have to select from this address data with name and city. Understood now? So which table you will be writing as an inner query and which as an outer query? Just think of it.
Payroll as inner.
Okay. So will it be like your subquery as correlated or non-correlated?
I think
Correlated.
non-correlated subquery, payroll one.
Okay. Okay, great. Because it will pass on only those employee IDs whose birth dates are coming in the month of February to be selected from address data with their name and city and country. So this is what you are writing. Name, city, country from address. It's your outer query where employee ID in selecting those employee IDs from payroll where the month of birthday is to order by employee. So this is what you see the output. So what will happen? First, it will work on inner query to select all the employees whose birth dates are in the month of February. So it will select these employees. And of course, it's a subquery which is querying single column. It will return either a single value or a multiple value. So here you will get all the employee IDs whose birth date is coming in the month of Feb. And this is an in clause or in operator with your where clause to select all employees in the list of your this employees for their name, city, and country from table addresses. Understood? Correct?
Yes,
So you know what is in operator? So it's like select all the employees among the list of employee IDs. Agreed? That's
Yes.
why you wrote in operator. You did not use equal to sign because equal to works only to select single value, but you have multiple values, therefore you used in.
okay.
Correct? All
Yes.
with me?
Yes.
Yes.
Great. So this is what it's telling then. Second step, pass the values to outer query for your where clause to subset. So you get all the employees who are having their information with name, city, and country from the month of Feb birthday. Okay, open this activity they are telling. Change the in operator to equal to sign in the code. Run the changed program and review the SAS log. Go ahead and open this activity A01. So they have asked to change in operator to equal to sign and execute your query. So what you see? So what did you get?
Getting error message.
Error.
So what is that error?
Subquery evaluated to more than one row.
So what does this mean?
Mm.
I've already discussed it. Why we wrote in operator and why not equal to? Because your values are not returning a single row, because equal to works like where employee ID equal to single value. Hence you write equal to with a single value, but here you have multiple values. So when you have multiple values, you cannot use a operator equal to. That's why it's telling subquery evaluated and it's having more than one row. So you cannot use equal to sign to select the rows with single value. Understood now?
Yes, Rashmi.
Yes.
Yes.
I'm getting result. What am I?
Monica, you're getting result.
Yes.
Did you write equal to by removing in operator and wrote equal to sign?
Okay.
Did you
Employee
change
ID.
that?
I have.
Yeah, in your outer query, that is what the activity is. You need to remove in operator and write equal to sign. See this? I
Mm,
hope you can see my screen. Change
yes.
into equal to and now execute it. You will get error.
Subquery value more than one row. Yes.
Got it?
Yeah.
Okay, so multiple choice poll now. What happens when you change the comparison operator to an equal to sign?
Message. You get an error message.
Error message.
Absolutely. This is what you wrote, you got it. Subquery evaluated to more than one row. So when a subquery returns multiple values and the equal operator is used, an error message is generated. So if your subquery returns multiple values, you must use in operator, or you can always use this compare operators of comparison with your equal to sign, all or any keyword. If you want to use equal to sign, but you do not know whether it returns a single value or multiple values. So in that case, if you write equal to, see to it, you can always enhance this activity by using this keywords any or all. So how does this works? So if you write equal to any, it works like this. That means if it's returning the subquery with multiple values, it will be equal to 20 or equal to 30 or equal to 40 if you write equal to any like this. So in our case, we had used in operator, correct? We had used in operator earlier. So earlier in operator, it returns multiple values. So here it will be employee ID, comma, second employee ID, comma, third employee ID, correct? If the same query, I use it, I want to write equal to instead of in, but I do not know whether it works or it returns a single value or multiple value. So I write this keyword n, this. Okay. So let's see if it works here. Yes, it's working. Okay. So there is no any special error message. That's what it looks as if it's equal to 20 or equal to 30 or equal to 40 if you write equal to n. But if you write, if you have any comparison operator where you want to select the values greater than some value, okay, so in that case you can write greater any. So whatever the values it returns, so it will be any means the lowest value. I select all the values any which is above 20. So that will be like this. Okay, and if you write this sign less than any, it means less than the maximum value it returns from 40. So this is the examples where 20, 30, 40 are the values written from your subqueries. Is this clear, everyone?
Yes.
Yes. So you can write all also. Greater than all will come like this, or less than all it will be like this. So all expression is true if it is true for all the values returned by the subqueries. So the values again 20, 30, 40 is representing from the query results. All right.
Yes.
So scenario here is, now understand, senior sales executive asks the following. Do any level 4 sales representative have a salary that is lower than any of the lower level sales representatives? That means you want to find out from the employee titles, that is your sales representative level 4. It's telling, do any level 4 sales representative have a salary that is lower than any of the lower level sales representative? Now you know level 4 means as a higher level maybe. So lower one, two, three is lower level maybe. So you want to find out, is there any employees who are having salaries lower than the salaries earned by level 4? Okay, so this is what they are getting the result, which is expected from us. So for that, you can use this any keyword. So you're using employee ID, salary, staff, job title, sales representative, level 4, and salary less than any. Select salary from staff where job titles among this representative 1, 2, and 3. So you get all those employees who gets their salaries less than your level 4. So either you write any, or you can also write max of your salaries for this employees. Or you can use this max keyword also. Maximum salary. Either use any or you write max. Greater than max. Understood everyone? So you get this employee IDs. So level 4 sales representative who earn less than any lower level sales are those employee IDs. All right. Any queries on this demo? D05. Either you write any or you write max. Okay. If you have no questions, come to this exercise. We are working with chapter 5. So before coming to this level 1, do the demonstration for your slides which we have completed, which is demo D05. Open this demonstration, work on this, and go ahead and do your exercise, which is on page 5-18 level 1. All right, go ahead people, do demonstration D05 and move with this exercise. Recording. So let's move ahead with inline views. So we had seen one part of a query written within a query. It's called as a subquery. Now we'll see a query which is written as in a from clause. Okay, and that is why it's termed as an inline view. So what is it? Let's see in detail. So how we write a query in a from clause. So we'll create and use your inline views, and we'll use inline views and subqueries to simplify coding a complex query. So list all active sales department employees who have annual salaries significantly lower, less than 95%, than the average salary for everyone with the same job title. So what you have to do is, you have to list all the employees from the department sales who are active, means who have not left the company. Okay, they are still working with company, who have annual salaries significantly lower, which is less than 95%, than the average salary for everyone with the same job title. So you have to find out, in case you have the job title representative, sales representative 1, who are having less than 95% salaries average with the same job title people. Okay, so this is what you have. Their average salaries overall for the same job title and individual average salaries. Are you getting it? This is what we want to do it. Understood the report, what we have to do, everyone? Yes, no?
Yes, Ashwini.
People, wake up.
Yes, Ashwini.
Okay, I could see only one
Yes.
boy here, voice. Yeah,
Yes,
Priyanka,
Ashwini.
thank you.
Yes.
Shanmuga,
Yes, Ashwini.
okay. Monica, Padma,
Ashwini.
okay. So step one, what we have to do is we'll calculate the average salaries for active employees in the sales department grouped by job title. So let's use payroll organization table. You're joining on employee ID and you're selecting those employees who have not left the job. So their term date is missing and department is sales. Columns you are querying job title, average salary, and you're grouping by job title. So you get all those people who are earning are having their average salaries, okay, calculated, and who have not left the company. So this is what you get the job titles. So you're getting overall for every job title, its average salaries. So within the same job title, you want to find out any employees who are earning less than this average salary for sales representative 1, for sales representative 2, and that is what this is required. This one. And that is what we had this average salaries for sales representative. So compared to your average salaries who are earning less than that, which is less than or lower than significantly 95% individual employees. Okay, so first thing we calculated average salaries within every job title, hence you had grouped it. Next step, what we have to do is we want every individual, this is what we had got, right? Then we want to know how can we find out individual employees earning less than average salaries for each job title. So this is the question. Can this select statement be used as a subquery? Look at it, what you are writing. Job title, you're querying average salary from the same payroll organization data which you had written earlier, which you have got average salaries for each job title. Can you use it as a subquery?
Yes.
Are you sure? How many columns it is querying?
Mm, No, one.
Yeah. And we cannot write a subquery which queries more than one column.
No.
Agreed, everyone?
Yes, sir.
So this query you cannot be used as a subquery because a subquery must return values from a single column. So this query now we can use it as an inline view. So what is an inline view? So in your from clause, normally we write a physical table as a reference as an input table, correct? Instead of that, we can write a query which acts as a virtual table when it is executed. So what is an inline view and what is a view? I'll explain when we are coming to that slide, but just understand it's a query expression that is your select statement which resides in your from clause. It acts as a virtual table used in place of a physical table. So instead of writing an existing table, you can write a query which is called, or when it is executing this code, this query will first create a virtual table. So that table is no more as a physical, but the query result will act as a virtual table, and that table acts as an input table for this from clause. So hence it's called as a view. Why? Because the code which is written within the code and it's giving you a virtual table, that code is called as a view. So it's not at all going to have a representative of a physical table in your from clause. So hence it's called as a view. View is nothing but a concept where you're simply writing a code and you're using that code to be executed during your query as a virtual table, because that code will create a table and that virtual table will be used as an input table. Hence, that code is called as a view. And because it's written in a from clause, it is termed as inline view. So an inline view are often useful when you build complex queries. Why? Because you cannot reference huge tables in a from clause. So in that case, you can always write a query in a from clause where it will fetch in the data in this query and work as a virtual table as a view. Hence, you use most of the time inline views when you're using complex queries. Getting it now? So this is what it's telling. See? So this select where it generated this result will be a virtual table. So it's nowhere a physical table. This will be a virtual table, and from this table, it will be able to select the employees who are earning less than 95%. So see, you're writing a query, employee name, job title, or job average, which is you're calculating average of salary. Then you're writing an inline view, and for this inline view you're writing in parenthesis and giving a name as job. So this job will be its nickname for this virtual table for the result of this query. And this you are joining in from sales staff, where you are selecting only job titles is same with staff and this query result of inline view, and salary is less than, sorry, greater than your average salary into 0.95. It's because you're selecting lower salaries less than 95%. Getting it? Hence you're writing this expression. And employee term date is missing, of course, and order by. Of course, we want those employees who are still working with the organization. So the query which you have written in your from clause in parenthesis is called as inline view. And this code is termed as a view. Why? Because this code, when execute, it generates a virtual table which you are giving a nickname as job. And that is why it is called as a view, and it's written in a from clause, hence it's termed as a inline view. All understood, people, everyone?
Yes. Yes.
Yes, Shanmuga,
Yes,
Swarupa,
sir.
Nilima, Padma. Great. So if this is clear, this is where you get those employees. Hence, it's termed as a complex query. But set up for the poll now. Understand here. See what they're doing. You're writing this inline view in this from clause as job. This query is ending your. Okay, then you are writing an independent query, job title, job average from job. This job means this query inline view is named as job. So will this work? What do you think? Will it query this job, which is actually the inline view? What do you think? Yes. So your first select statement light writes an inline view to create the data that is reinforced or referenced in your alias job. Job can be referenced in your second select as if it's a table where you're querying it?
Yes.
Will it work? So Monica is telling yes. How about others? It's a poll. I want a poll. I don't want a monotonous answer. Yes, people, what I said, inline view is a virtual table it creates.
So should we create different virtual table for every select statements?
Understand, this is in a view. It's actually a query. It's a view. It's a code which generates a table. So it will be active only till this query is executed.
So now
It's an
for this cell,
independent query. So
yeah.
this will not work on job. Why? Because this query result work created as a virtual table worked as a from clause as an input table for this outer query. Finished, done. Its work is over. Where you try to query it again as a table, it's no more there. Why? Because it's only temporary available for the execution of this query. Got it now?
So it will not work for select.
No, for second select it will not work.
Oh, okay. Only for first.
It's a temporary virtual table. It will over when this query ends here.
Oh, okay.
Understood, everyone?
Yes.
Yes. Yeah.
So the first select statement uses an inline view to create a data that is referenced in with an alias job. So here it's telling no.
No.
An inline view can be referenced only in select statement where it is defined. That is here.
Okay.
Hence, it is mostly recommended to use inline views when you're writing complex queries with huge data. Got it now? Why? Because the space is the most important factor of your memory processing is also important factor. It should not take long time to query huge table. So it's better to use inline views. All right, everyone.
Yes.
Yes.
This is all about inline views. That's it. So now let's understand the same through a scenario. I'll just complete this and we can stop. Okay. So business scenario here is management wants to incent more sales of Expedition Zero sleeping bags by rewarding each sales associated who sold these items in 2011 with a $50 certificate reward. So what they're trying to tell in short is management has taken a decision for those to give a reward for those employees who are able to successfully sell a product called as Expedition Zero bag. Okay. And they want to give this only for those people who have performed the sale in the year 2011 with this $50 certificate. Okay. So the task is you have to prepare all those managers list name and their cities for those or the employees who are been qualifying for this certificate. Okay, so that is what you want to provide this reward. Of course, it's not given directly to the employee. It's always first intimated to the managers and the managers gives those rewards to the underlying employees. Hence, first we need to find out those managers with their name, address and cities. So for that, we have the information saved in 4 different tables. Order fact is a table where you have order placed information for which product, which date, what is the order, that is the product ID. Then product dim is the table where you have the information of product. Of course, dim means its demographic or its dimensions of product, that is the name of the product ID, okay, all those things. Organization is an employee information where you'll get the managers and employees. And of course, employee address is the in data where you have the information of their residential details. Okay. So this is, you have 4 tables. So it's telling in this business scenario, because this query involves 4 tables, it might not be necessary or easy to code all at once. So to simplify the task, split the query into 2 parts, test each part individually and test overall query with each time that a new segment is added. So let's split. First part, identify those employees who sold Expedition Zero merchandise in the year 2011. So where you'll get this information? You'll get this information from 2 tables. One is the order fact table and second is your product table. Correct? And of course, they're telling identify employees. So your order fact, will it give the information which employee was successfully able to sell this order fact table? Okay, so let's see that also. So find employee ID identifier for the managers of this employees. And of course, we can obtain manager's name and city's information. So these are 3 parts of your query which we need to work on. So first is we need to find out employee IDs who have sold this product Expedition Zero in the year 2011. So each employee ID from results of joining order fact and product name. See what I said you? Takes product ID, or you can take this product ID from this product name table where the product name contains the word Expedition Zero. And we want to exclude all those employees who are performing the sale for the organization, who are doing the sale through internet and catalog. because at internet and catalog there is no employee ID. Hence the value is this 8 times or 9 times 9, because we cannot give a null value because later on you can add the values. Hence universally we write this, because internet and catalog type of sale, people never have any type of sales representative performing sale. Agreed? Because it's a self purchase. You go to internet, from the website or from any of the catalog sale, you select the catalog item or the product ID and you purchase the product. Correct? So there is no any sales representative taking any type of role to sell this item. So you cannot use internet and catalog orders. All right, agreed with me everyone?
Yes.
Okay, because we want only those physically those who have done this sale when the customer has reached out to the retail stores. Okay, so there that employee has his personal contribution to sell that product. Correct? So that is what we want to find out. So hence you write a query first part, distinct employee ID from order fact product dim. So you have two tables where your ID from both the order fact and dim is same, and you're selecting from the year 2011 when the date of order. Here is the function which extracts the year, which is equal to your 4 digits year value. And the product name contains expedition 0, and of course exclude all the employees which is not equal to this. Why? Because in your data you have employee IDs with the number this. Now this number indicates that those employee IDs, or there is no employee ID because the sale is performed through catalog and internet or internet. Hence no employees with this number. So you are returning with one employee now. All right. So if you got this employee, now what is the next process?
Manager of that employee.
Correct. So you need to locate the manager and the residential address of that manager. Hence, you will be using organizations and your which
Yes.
table?
Addresses.
Addresses. Absolutely. So this is the second part. That is what it is. First part, find identifier for the manager of this employees. So this is what it is. But before it, you have a poll, or second part it's telling find the employee identifier for the managers of these employees. So what we have to do is we are going to select managers or manager ID from the results of joining organization table with the first query result of your ID. Hence, it's telling to join your employee organization table with the first query result, you use the query from first step as which of the following, either an inline view or as a subquery. What you will use? The first result to select this query from the managers from your organization data. Will this query be used as a subquery or an inline view? What do you think?
We can use an inline view for that.
Inline view?
Yeah.
Everyone agreed? People.
Yes.
Yes.
So to join employee organization table with step 1 query results, you use the query from step 1 as which of the following. So you can use it either an inline or an non-correlated subquery, either of A or B or neither. So you can use it either A or B. All fine? So this is what it's done. So you want to select manager ID from organization table and you write it as a inline view. All fine? So you write a query to obtain manager ID of this. So you write it as an inline view. See, it's telling in a from clause, comma, a second query or your first query result. So this is which it will represent one employee. Correct? So you'll get one manager now. Fine. So write a query to obtain the manager ID of the employee's manager. This is what the query is. Correct? So you got the manager. Now the third is you want to find out the manager name matching with its manager ID or addresses to get its name, address, city. Hence, now the question is it possible to use the entire query of step 2 as a subquery?
I think we can use that.
It is querying single column. So will it be using subquery?
Because single column
Yeah,
we cannot use.
we
So,
cannot use. We can use because it's querying single column. See, it's querying only manager ID.
single column.
Correct. It's querying single column. It may give you multiple values, but it's querying single column. So what is a prerequisite of a subquery? It should be returning only single column querying. Correct? Agreed?
Yes, yes.
Yes.
So you can use it as a subquery. You can. It's just trying to tell you, okay? So subquery can return values for multiple rows, but must return values for only one column. So when submitted on its own, the query in step 2 returns one row and one column. So it can be used as a non-correlated subquery. Correct? So this is where you write your part 3, where you are writing employee name, city to be selected from address, where employee ID in, and you write a subquery where you write or you get the result of this subquery as one manager with its name and city will be getting from address. Correct? So this is a subquery. So as a whole, your whole coding looks like this. So you write a subquery. Within a subquery, you have an inline view. All right. So this is all your overall query and you get that manager with its name and city. So this is what you return. But the same thing, if you do not want to write a subquery, if you do not want to write a inline view, you can simply write this way. Look at it, order fact, order name, employee organization, address. You're giving its alias and you're telling each table is having an alias. So product ID is common, employee ID is common with which table? It's common with your organization and of course with order fact table. See, correct? Then again this employee ID from organization is common with address table with manager. Product is same from order fact and product table. And you are subsetting data on product name which contains expedition 0, year and employees who are not equal to this value. So the same result will appear as you write it earlier like this. So if you don't want to use all this, you can use the physical table names in your from clause like this. All fine, everyone?
So this cannot come under subquery part.
So you're writing everything together.
Yeah.
So there is no subquery, there is no inline view.
This is simple.
This is simple, but understand this is a classroom table, so those are very small. But when it comes to at organization levels, when the tables are huge and you are need to um, at, like query those table at database level with various data sets, then in that case you cannot use this physical form of table. So in that case you have to make use of inline views or subqueries. Getting it? I
Yes.
hope I'm making some sense.
Yes. Yes.
Yes. All right. So this is all about your complex queries inline views. So demonstration D10 and D11 is the thing which I leave up to you as a part of a self-study along with its exercise. All right. Any
Okay.
questions? Yes, people?
Not.
So far, actually.
No, okay. So with this note, we can stop for the day, but see to it the demonstration for this topic D11, D10 is to be done along with the exercise. Okay, so let's stop our day. Wish you good night. Take care. Bye. Thanks for
You.
attending the class. Yes, thank you. Bye.
Yes.
Thank you.
Thank you.